hopefully it will make your life easier when you want to extract data. So my journey as an XMM user, so I started, I guess, as everybody else, if you have already worked with XMM-Newton data, so I started from bash scripts. So I followed, during my PhD, the basic steps, and I installed all the softwares that were needed. So I was working with Newstar back then, so I installed HeSoft. I have a Linux, and I installed all the other dependencies, and I did the same for SAS, and I installed everything following the instructions. But maybe some of you, like me, I don't know, also struggled with the installation because there are always like things that don't work. You are not in the right folder. You don't have the right permissions to do this and that, even more if you work on a laptop that is managed by your institute. So I struggled a lot. And to the point I managed to do it. And in the end, the other people in my own institute were asking me how to install this software on their machine. So that was an interesting experience. So once I finally managed to do all of that, then as you may guess, there are updates, and then you have to do this all over again and again. And so, as I said, my whole journey was failure and success and failure and success every time there was a new update. And I was almost getting nightmares when there were new updates, even though I was also looking forward to them because there's a reason why there are updates. But I spent really a lot of time on this. And then that's not it. Then of course you need to do your spectral analysis. So then you go through all the threads. So I must say that for XMM-Newton, it is really well explained. The documentation is highly furnished. You even have now Jupyter notebooks for that. So it's really convenient, and I can't complain because there is documentation. But as you can see, there are a lot of steps. And I also struggled with that, of course. I had also my own problems. So I was a bit like switching from one mood to the other, like complaining and happy that it worked, and then vice versa. So it was a long journey. And then how it looked like. So I managed to combine all of these in a few bash scripts that work very well. I even managed to customize a bit my own setup. I'm not an expert of bash scripts, but I still managed to I don't know, implement a little cow asking me some questions in my script. So I found it a bit more interactive. And that's the thing I was looking in these scripts for, some interactivity with the user. So it worked. But this is how it looks like. And so this is only usable by me, I guess. Probably I can share it to people, but I think they will suffer also. Even if there is a nice cow talking to them, I think that they will still suffer. I managed to share this to some of my colleagues, and they were happy with that. But yeah, it's, I mean, the person who wrote this is the person who is the most able to explain it to other people. So me, in this case. So yeah, that was my feeling throughout my whole time as a PhD. And then when I arrived at ESA a few years ago in 2023, I discovered something called ESA Datalabs that I had never heard about before. And all of these scripts and all of these threads, you can actually combine them. I managed to combine them in one Jupyter notebook, where you just need to click on play at the bottom here, at the top here. You click on play, and it does everything that I showed before. Also, of course, I had to write this, but I could use the Jupyter notebooks that were already written in the SAS threads, and I combined with my own customization and on things I wanted to do. And it works, it really works. That was impressive. I was super happy with that. And I did it only very recently. So most of my publications are without this, but now I really plan to use only this for now. And so let me explain you, as from the user point of view, some of the advantages of ESA Datalabs. So first, it runs on a Jupyter Lab interface. So if you are familiar with Jupyter notebooks, then this is the right tool for you. I was used to Jupyter notebooks before, so that was great for me. It runs with Python then, so you can run the SAS commands using PySAS. So this is simply exactly the same commands that you use in your bash scripts, but Python version in the Jupyter notebook. And you don't need to install anything, neither any other dependencies. This is not your problem. This is the problem of the developers. So this is great as a user. And at the moment, you have two versions of SAS. You have SAS 21.0 and 22.1. It's important because in case you want to go back to a previous version, you don't need to I don't know, delete your own installation or do another environment. You just open the Datalab instance that you want to use, either SAS21 or SAS22. And of course, you have there all your favorite Python packages for interactive X-ray data analysis. So I'm just like citing a few of them. Maybe you are familiar with those. Those are the ones I'm familiar with. And just as a little note here, sorry, did I miss it? Yes. As a little note here, JAXPEC, because I was a co-developer on this. It's like XPEC. It's not a wrapper. It's an X-ray spectral analysis software, and that is fully based on Python. And here we have the few publications that we have done for this software. So the nice thing with this, it is still under development. So that's one of the main problems with this software. But the good thing is that you just do pip install JAXPEC and you're done. So you don't need HeSoft as you would need for XPEC or other dependencies like ISIS, for example. I was using ISIS before, or other softwares that you may have heard of. Just some self-advertising. So, and then once back to ESA Datalabs, once you are there, you will see these things. So here is the vocabulary that is linked to the ESA Datalabs. So this is called a Datalab instance. So here I'm showing SAS 22.1, but for example, if you work with other missions like the JWST, Euclid, or any other missions, you will see in the list of the ESA Datalab instance that you have on ESA Datalabs all the other softwares you might be interested in. So in this case, XMM. And then you just click on play. So here it's not it's already being run at the moment. So you just click on play, and then you're there. It's done. Like it just needs to load for a few seconds, and then you're there, and you can do all of your SAS comments. And this is called the data volume. So here you have the calibration files that Aitor mentioned before, and all the SAS threads. So again, with the calibration files, you don't need to download anything. You just associate the data volume to your account, and you also associate, if you want to see all the SAS threads directly to your account, so that you don't even need to copy paste from the web. You have everything there directly in your folders. You can interrupt me at any moment if you have any questions. Okay. So here, I think if I have good internet, I can do it myself. Let's see. Otherwise, I will show you the video. So a little go through. Do people online see my screen at the moment? Yes. Okay. Okay, so let's go back to the beginning here. So this is the ESA Datalab homepage. So Datalabs homepage. So here you have some information, what it does, blah, blah, blah. So as a user, you will see different menu here, and what can be helpful for you is the help, of course. And then here you have the explanation of all the things that you can find on this website. What is the ESA Datalab? How do the data volumes work? The workspaces, and everything that you may have. That you may, I don't know, some questions you may have, and then you can also contact directly the user support if you have other questions that are not written here. And if you are super familiar with this, you can also be more on the developer side, but also you will have the questions that are written here in the help. And then what you will be interested in as a user are those little tools here. So you have the first, where you will find all your Datalab instances. And then here you have the data volumes. Here your workspace management system. And here notification account. Yeah, we don't need that. So if I go here, so here, as you can see, I have already two of my Datalab instances that I'm using. But if you want, actually, I will delete this one. Yes. And then if you want to launch a new one, you just type in the search bar here what you're interested in. You can also see everything that is available here. So there is a lot, I don't know, anything you can be interested in. Maybe not everything, but actually if you have suggestions, you can contact the user support. And here in our case, we are interested in XMM here. And then here you can find, as I said before, SAS 22.1 and 22 and 21. Okay, and so I have already launched it. So then you just click on launch, and then you have it here. And then when it turns green, that means it is usable. So at first you need to click on play, and then it becomes like this. And then you just double click. or just click once, but have internet issues, so maybe this will not work. But we will see it at the tutorial this afternoon. Yes. So once you click there, if it works, yes. Here you have your folders that you have on your account. Maybe I have a bit more than you, but here this is what you will use mostly. So my workspace, and then here you do everything that you want to do as if you were on your own laptop. And here on the right, you can see I have a terminal window that is open. And for example, if I type a SAS version, which is a SAS command, we can see that it is installed, done, set up, everything. So you can still work in bash scripts and bash commands if you want to keep it the old way, that's fine. Or if you want to use the Jupyter notebook, here I have an example that I will show this afternoon during the hands-on session, and where here you have all of the things, and then you just run them, and then it does the job that you want it to do. And then you have also other tools. I'm going a bit quickly, but we will go into the details this afternoon, no worries. So you have JS9, which is DS9, but based in this environment, Python, and then, yes, the basic tools that you probably need for your quick analysis, or at least to extract the data. And then if you want to do fancy things, you can go back to download the files and then do your own things on your laptop. And I think that's it. Yes, I didn't mention the data volume. So here, this is what I was saying. You need the calibration files. If you want to have the SAS threads directly in your folders, you just add data volume. So here are the two data volumes I'm interested in. You can delete them, add them again. It's fine if you did a mistake. You just delete and do it again. And then they will be available directly here in your folders. So for example, here it goes in data, user, and then here I have all of the SAS threads. Here, I just open them. I can run them, copy them in the files, in the folders where I want them to be. And then I have also the calibration files. Yeah. Well, all the calibration files. And it was just like me clicking on a tool and it does it directly. Okay, now let's go back to the presentation. Okay, so I think he's just like what I showed before already, the different vocabulary that we use, where you can find the threads. We also have some tools, as I said, JS9. You have also some Python code that was developed by people at ESAC to plot some light curves, to plot the events in an interactive way. So you have also these tools that are available in your folders if you want to use them, and for easy visualization and interactive functions. And here is just an example of what I'm just mentioning now. For example, if you use plot LC, you will have here on your left, I don't know if it's super visible, but you have the light curve. And if you hover your mouse on the data, you will see interactively the value of the data point. You can zoom in, zoom out, do a few things. And here on the right is the JS9, so DS9, but based in this environment where you can do the usual things that you do with DS9. And it's everything in the same environment, so you don't need to go back and forth between different laptops. Okay, so now I will go into the details of a few things to watch out for bright sources with EPIC or RGS. So this is very specific because this is the things that I've been doing mostly during my PhD. I've been working with bright sources, and there is some vocabulary that maybe not all of you might be familiar with, so I will just mention it quickly for your own knowledge. So here we have again this XMM-Newton scheme, and then we see EPIC-MOS 1 and 2 and EPIC-PN. And here for EPIC-PN, I showed the example of the different modes that we have, as Aitor mentioned this morning. And here you have the full frame mode, the different window mode here. And what I am interested in is the EPIC-PN timing mode. And here, the advantage of this mode is that if you have very bright sources, you need a resolution time that is very, very small because you have so many events that you need to be able to read all of them. But why is it giving this stripes? Maybe you already know, but sorry for those of you who already know, but the basic principle is that you have your detector. The photons, they come on your detector. And the way that the timing mode works is that you have all of the rows that are collapsed into one row, and this is being read out. So if you have, for example, this pattern, you collapse it, and then in the end, so I try to use different shades of yellow. I hope it is visible. And then you collapse everything at this first frame, and this is what you get. And then at the second frame, you do the same, and then you get the second row, etc. So you lose the spatial information in the y-axis, so that can be annoying. But you get an information about the time. And then on the x-axis, you still have the information to the spatial information, and etc., etc. So as you can see, here we see why it does this pattern, this long rectangular pattern, because if you have a bright source, a point bright source that doesn't really move, it always stays at the same place. So every time you will take a frame and it will be collapsed, then you will get this rectangle, long rectangle. And when you have these kind of sources, the problem is that they are very bright, and there is something that is called pileup that can happen. So what happens during pileup is that you have an X-ray photon of a certain energy, and the problem is that for bright sources, we have so many events that sometimes during one readout time, they will collect several events. But the problem is that when it will be read out, it will be read not as two events, but as one single event. So for example, you have an X-ray photon of energy 1, another X-ray photon of energy 2, but if they come too fast during the readout time, they will be read as an energy E1 plus E2. So how can you, and what happens is that you will have an excess of photons at high energies, like a false, it's a false effect, because you are not supposed to see so many here. You have what is called the, what is called this tool again? EPICRGS plot. And so you have the EPICRGS plot, and here it shows you the pattern, and you can see this excess of high energy photons caused by the pileup. So how can you reconstruct E1 and E2? Well, the answer is that it's not possible. So the only thing that you can do, is to remove the columns that are affected by pileup. So you will lose a signal, but usually when you have a very bright source, you can remove a lot of signal that you will still have signal to analyze. Trust me, that's true. So like for my analysis, I think in the end I only worked with maybe 6 or 7 columns, and I still managed to do analysis. But I cannot confirm that the data I used was not piled up. Maybe there was still some left over, but this is how it works. So you can never reconstruct E1 or E2. I hope I've been convincing. And if not, I'm sorry. So let's start the data extraction with a very quick example with a source that is called VELA-X1, which is a high mass X-ray binary. And don't worry if I'm going too fast. We will see all the details in the hands-on session this afternoon. And if you cannot come, it will be available online. Very quick scientific introduction about the source. So this is a high mass X-ray binary with a neutron star, and it has a very heavy and dense stellar wind. So when the neutron star orbits its companion star, it will accrete the material and leave behind this tail of a very dense and clumpy material that I am interested in. And there is ionization as well. There are lots of things happening there. It, of course, affects the accretion rate and the X-ray emission, so that's why it's a super interesting source. So interesting that I published three papers about this source. So with different instruments, we have NuSTAR, XMM-Newton, and Creden. So if you are interested in the details of the analysis, you can go to these papers. And just as a side note, only in the last one, I used the ESA Datalabs, because before I didn't know about it, so I used it only for the last one. Okay. So as Aitor mentioned this morning, it's just that I summarized with bullet points. We do the SAS startup. So you import all of your pattern libraries that you want to use in your Jupyter notebook. You define the path for the calibration files that you have mounted as a data volume. And then you choose the observations that you are interested in. And then you do all of the start steps. So it's explained, no worries, just a few comments. Once you have done the startup, then you can reprocess the ODF data to generate the EPIC event list. So here I'm showing you the example of VELA-X1. You use EPICRGS, and this is what you get. Here you get the events. And yes, as a side note, if you don't want to use the default calibration of EPICRGS, you can also customize your own calibration. So EPICRGS has some arguments that you may want to change for any kind of reason. So I needed to change a few things because I had a very, very bright source, so I had to change a few things in the default calibration. And then you generate the image, and this is what you get. So here we can see the very bright VLAX1 that has been collapsed. So in the Y, we see the time, and in X, we see the position in the sky. And then we need to check for flaring particle background. So for that, you extract your light curve, and you check if there are some flares happening, and then you filter them. You do it only at high energies, because in the case of my source, it is so bright. It's flaring all the time. So in the end, I don't think I needed to filter for flaring particle background, because here, this is in blue the threshold that is set by default, and here in red is the data. So I will not filter out all of the data. It's not all flaring particle background. It's just that my source is super bright. But this gives you an idea, like you just follow these steps. If you have a fainter source, you just check where it will flare above the threshold. You can adapt the threshold depending on your source. And I had also simultaneous new star data, so I could see that the light curves were similar. So I knew that it was not flaring particle background. But still, this is a mandatory step that you still need to check to be sure everything is okay. Okay, then that's what I do. I know that not everybody does that because you don't always need very accurate times, but in case you need very, very accurate times, or I don't know, timing analysis, you can use you can do barycentric correction, and then here you have the steps that you can do to do that. And okay, so now back to the case of complicated case of bright sources. So now we will do the steps to do the pileup correction. So here you have again your image. So what you do is that you extract the source region. So if we go back, I went a bit fast. So here, the source region is this very bright stripes here. So you extract it. So when you extract it, that means you remove the rest. They also tell you that you can extract a background region. But in my case, when I was looking at the columns of the background, the source is so bright that even the background was looking like the source. So in my case, I didn't need to extract a background, but the normal case is you will need to extract a background. But if you are in such cases of bright sources, you don't even need the background. Then you check with EPICRGS, as I showed before. And what you see here is that there is an excess, the pattern is not okay, so we need to correct for pileup. And the criterion for this is that you need to have the fraction here. I went a bit fast again, sorry. Here you have some numbers here. You don't need to pay too much attention to them, but the aim is trying to get these numbers as close to 1 as possible. So what you do is that you start from the middle of your source region and you remove columns. So you start by removing 1 column and you check again the EPICRGS. Then you start, if it is still not okay, you remove 3 columns and you check again the EPICRGS, etc., etc. And you will see that when you remove everything, this is the moment when you get the closest to 1. So you have to find a good balance between keeping enough signal and removing enough piled up columns. So this is not always easy to decide, but yeah, you have to find a good balance. And in the end, my good balance was this pattern. So I worked only with these columns, and you are still able to do very good science. So I removed the rest, I removed the most piled up columns, and this is what I get in the end. Okay. Okay, some details why the reason for SAS 22.1 is that you have some shifts for bright sources in energy. So you can see it with the iron line, and you will see that the value of the iron line is a bit shifted. So you can do this extra step of energy correction for energy scale effects. So basically, you can follow the thread online. You check at instrumental edges that it corresponds to what you have on your spectrum. And if you see it is shifted, as you can see here, it is a bit shifted, then you apply a correction to your events. You say, at this edge, instrumental edge, I got this amount of electron volt of difference, etc. So you do it 3 times to the 3 instrumental edges. And then you apply the correction to your photon events, and then they will be all shifted. That's how it works. Just follow the thread. It's not complicated. And then now, when I apply the correction, you can see that it follows corrected the expected line. And then Finally, you can perform your data analysis. So you extract your light curve in the energy bands that you are interested in. So for example, here I decided between 0.5 keV and 10 keV with a certain time bin, which was the pulse period of the neutron star in this case. And here is the nice light curve that I got. And then you extract the spectrum. That's the logical next step. And so then you can check the ARF, the RMF to see that as a sanity check that everything is working. And then you can plot your spectrum. And the nice thing also with the Jupyter Notebook is that you can do it interactively. So this is an interactive spectrum where when I put my mouse on it, I can see all the details about the value of the data point. I can zoom in, I can zoom out. So it's super nice. So this is the spectrum. And when you have enough photons, you can even do GTIs with time interval. And then you just decide for a T-start and a T-stop. And then you can extract different spectra in these time intervals. This is what I've done. This is the same comments than before. It's just that you use this additional argument here in the F-select, and then you extract the spectrum. And here you can do different time average spectra. So here I've done 3. So I extracted during the first third of the observation 1 spectrum, the second third, and the last third. And this is what I got. So you can do pretty much everything that you want to. And I hope I covered more or less all the possible examples. So with this example and this presentation in general, you learned, hopefully, how to work with sources taken in with EPICPN in timing mode. Hopefully, I showed you that for some sources, it is very important to correct for pileup by removing the columns that are impacted by pileup. In any case, even if you don't have a bright source, this is a check that you still have to do for your sources. Most of the time, they are not bright enough, but sometimes they are too bright. And then you do the same steps, extract, as usual, extract the light curves, the spectra. Here I showed you an example using Datalabs with a known case study. And yeah, you can do all of your science in the same environment. Yeah, and then some special thanks to my colleagues. So yes, thank you for your attention. Sorry. Yes.
Just a question. When you removed your pileup counts, you removed all the columns, but you got rid of more than 50% of your data.
Yes.
How does this affect physically what you see in your count rates, your light rates?
Yes, but then you get less photons basically because you remove the. So in my case, I removed the centermost columns. So in these columns, there were also like some photons. And in the end, if you look at the light curve, there is slightly less counts because in the end, the source is so bright that even by removing all of these columns, you still get enough counts. But yeah, if you look at the light curve, I don't have it here, before and after pileup correction, and you just get less counts, basically.
And also, when you remove those columns and you create the light curve, you also take into account the fraction of the exposure that you have removed.
Yes.
Yeah. Okay.
So the bins, I mean, you're using 2-second bins, and you remove, I mean, half of the frames.
Okay, so the fraction of the
exposure is taken into account.
Okay. So what you're losing is small excess after.
Yeah, and also, like if you do different light curves in different energy bands, this is where you will see it because since you have an excess of high energy photons, if you will mostly see the difference with the high energy light curves. So, yeah. And then in the very soft ones, because then you get more counts at soft energies. So yes?
I'm not pretty sure whether I understood correctly the energy scale effects.
Yes. Yeah, I went a bit fast because this is very niche. Okay. Oh wait, I went way too fast.
Is it a non-linear effect?
Yes, it's non-linear.
Is it happening only in the timing mode or also?
I don't know where it ended up. So I don't know if it's only in the timing mode. Now it's a check I do every time because I also work now on observations taken in imaging mode. So I check it by default. And on that source, there was no issue. So basically what you do is that you extract your spectrum following the normal steps. And you will see it in the threads. There is one special thread for bright, several special threads for bright sources. And one of them is the energy scale effects. And the way you can have an intuition about it is that, for example, when I looked at my iron line that I know very well in this source, even more when you have simultaneous data, I saw there was an offset of almost 200 electron volts for the iron line. So that was a lot. So then I checked this thread. And what you do is that what they tell you to do is that you look at your spectrum and you check instrumental edges. So those are edges that are caused by the material that is on the detector. And those edges are known perfectly. We know exactly what is the energy of the edge for the gold and etc. And what you will see in your spectrum is that those edges will not be exactly where they are supposed to be. And you have 3 edges that are known in this energy range for EPICRGS. So you check, you look at your spectrum at the 3 edges, and then you measure the offset that you have between the known theoretical value and what you find. And you do it at the 3 things, and then you can give it to the tool. You say, for the first edge, I found this, the second edge, I found this, and the third edge, I found this. And then the tool will do the calculation for you. So it's non-linear, because if it was linear, you would only need just one. But for example, in Vela, at the 3 instrumental edges, I got 3 different values. So I
remember Matteo Bonazzi's talk about this a few years ago. It's a rate dependent fact. It's like filling charge tracks for the game.
But physically, it goes back because the reference for the calibration is produced by the rate of source that is right.
Yeah,
that's the reason.
I would say it's almost the charge traps on the TCD, but it's incorrect, but you get to high rates.
Okay.
I'm not sure if that's true to the case.
Yeah, for this level of intrinsic details, I don't know. Yes?
I have another question. In timing, does the rate concept appear also in the timing mode? Or you use the information about the rates, the pattern?
Ah, the patterns. You mean, like, do we use it in the timing mode? Yes. Yeah, you can use it. Yeah. You get it. Yes. Yeah. I mean, yeah. It's. I can show it to you in the. If you come to the hands-on session, you will see that I have an argument about the selection of the pattern and everything. So you have access to this information. Yes.
I have another question about pileup.
Yes.
It might be silly, but like even with your smallest integration time, you still get pileup.
Yes. Yes.
Like you cannot do triplet. Like you can add small images. Lowering the integration.
No.
Down to the statistics.
Yeah, no, it's a bit complicated. It is not for. I mean, it's really for very bright sources. There are even things that are even brighter than Vela X1. Many things that are brighter than Vela X1. But yeah, at least that's the only way I am aware of to correct as much as possible the pileup effects.
Because I come from a background where like every photo is valuable.
Yeah, I know.
Yeah,
that's what I'm being told very often, that I complain about having too many photons when people have just yeah, 2 different teams. Yes.
Can you repeat how can you spot ILAPs from the plot?
Yes, sure. Yeah. So you have a tool that is called, actually the best one is even before time mode. Yes, just a second, it comes. Yes, here. This one is very obvious. So you have a tool in the threads or in the tutorial that is called EPICRGS. So you type this command and it will show you this pattern here on the right. So S is for single events, D is for double events, etc. So here it shows you the fraction of these events. Well, you don't need to go too much into the details for that, but basically what you have to understand is that the more you follow the expected trend here, the better it is. So basically here you can see that the data, they don't really follow the expected theoretical trend that you expect for the fraction between these events. And you see here, at the beginning it is okay, but then you can see here, it is completely off. So that is a sign that shows you that you have an excess of high energy photons. And an excess of high energy photons is because you recorded too many photons that have a too high energy, and most probably it was actually double or triple or whatever events that had a smaller energy. And so the way it works in the thread is that they tell you to check this pattern and to look at these two fractions here, and you need them to be as close as possible to 1. So what you do is that you remove your columns, and then you will see these numbers will change every time you do the EPIC plot again and again. And then at some point, it will get closer to 1. I don't do it. I don't know how it is done. It's part of the software.
Just the calculation side.
Yes. But yeah, no, it is in the pipeline. Yes.
I have a question. I project in advance, or maybe you said it, I missed everything. But it's something I always assume very naively, you have all your science ready products on the archive after a few days and so on. You open your image. You just want to measure the position of a single source with the astrometric error. Is there a way? Instead of running the stuff, having a catalog of all the sources with it. I see an access, and I want to like the equivalent in XRP center. So there is just one thing. I have thousands of sources. One, and quickly, I just want to know what is the best astrometric position and uncertainty for this. Is there a way?
I think that's a question for Aitor.
Task which is called Iridium Analyze, that it computes Iridium Analyze. That and you have to pass a subregion and background region, but it gives you the centroid of the subregion.
Yes. With an error.
With an error.
Because also the error is unless one can put it.
But if not, I mean, if Natalie is connected, and you got the coordinates from the catalog, and that is the best coordinates you can get. I mean,
yes, but I have to run something to the
no, but you go to the catalog. I mean, you go to the catalog. You see your source, and this source, if it is 6, it must be in the catalog. So if you go to the catalog,
and there is a new one.
Yes, how often do you?
Sorry. My typical problem is this one. It's this one. There is a GRB and XRP, so it as usual. And that's it. And then 1 month later, 2 months later, I want to go there because I want to see the late emission. So I see a source or a possible source around there. I want to be sure if it is at a position consistent or not, or whatever. I mean, that's just in that source.
Yeah. I mean,
is there a quick way to do this? Or
in the pipeline product, if the source is bright enough to get an spectra, which is more than 10 counts or whatever, there you also have a coordinates, and I guess, I mean, pretty sure those coordinates that you have in the archive. I mean, it is private. If it is private, you cannot. I mean, if it is public, I mean, the coordinates of this indicative source, I mean, they must be as accurate as possible. I mean, I'm pretty sure the pipeline run this Iridium Analyze to get the center. And if not, I mean, Iridium Analyze with the event file, give you the center.
Because I did a very specific, I extracted a box and then I could observe in both the recursions.
I saw Natalie nodding while you were talking. Maybe she wants to add something. I don't know.
Yeah, I don't know if it was mentioned that so there's the POSCOR that you can do that can improve the position of your source. I don't know if that's what Aitor said. I couldn't quite hear what was going on, but yeah, if you want to run POSCOR, then you'll get a better position. So that takes stars that are in, not stars actually, AGN that are in different catalogs, really well-known positions, and then realigns the field of view.
Okay.
Yes. I mentioned this POSCOR, which is another task. But it's running the pipeline, so at the end, when you have them in the center of the position, it cross correlates. I mean,
with optical catalog to data catalog. So yes, I was aware of this. Yes.
So what we have in the archive is
okay. Thanks for Yes.
You can do it next week. Whoops.
That's not clear, but produced the image.
Actually, it's definitely not a Swift dependent.
So that would be a
It depends. It depends.
I will have in 20 years.
It might be knowledge, but it might be knowledge of the excellent PSF, whether it has or not.
Yeah, because it's just.
But they store
I
it
have to
separately.
I'm trying.
Okay.
No, please, because now you're having the mic.
Sorry.
Okay.
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 I think,
More questions?
is there anything else?
So let's thank again everybody.
We can recommend that too, right? Is that too?
Yes, I'm not for sure if the lunch is already there, but if not, it will be 7 minutes. So we can just relax.
Maybe we can use these 10 minutes. I mean, to cross check that we can all.
Yes, this is a good point.
So now
everything is okay for
So
the hands-on session.
now
So
we
you
have
can,
the hands-on session later, so maybe we can use these 10 minutes.
Yes.
First, I mean, are you all going to use Datalabs, or do you want to use the installation of your laptop?
Who is going to use the Datalabs?
Maybe Datalabs.
Datalabs
Was convincingly.
but because, I mean, if you want to install SAS, let me know, and I can. So now you can try to connect to Datalabs. I guess you all have an account, and we can go check that you can see the threads, the volume, and you can also check see the team space. So we have created that team space. One thing that is also good for them, in my opinion, with Datalabs is the collaborative aspect. So you can create a team space, which are directories that you can share with your colleagues. So if you are working with an analysis of Azure and you have your Jupyter notebook, you can create this team space with your colleagues, and you share the Python notebook, and your team can change it, running or editing or whatever. And it's the same. So we have created a team workspace where we have uploaded, I mean, a couple of threads, one for RTS and two for Epic, in case we want to use it this afternoon. So cross-check that you can see this team workspace, and if you don't see it, let us know, and we see why not. And yeah, so
Yes, if you one is a good moment to try.
You can open the.
Maybe you want to show how to with your own account.
And
Well, mine is already.
you go to the.
Not sharing on the.
Yeah, I closed it. My
Sorry.
bad. My bad. Where was it?
Yeah.
So you have to if you go to the home.
First, you go home. You go to home. Sorry. And then you click here on Launch New, if you have already your account. And then here you type in the search bar XMM. Actually, I will delete mine, and I will do it with you.
My workspace, I mean, as Natalie mentioned, is a persistent volume that you have. So anything outside my workspace directory, it disappears when the data is closed. Right? So you always have to work in my workspace and put the data there. That is the persistent volume.
So now you typed XMM in the search bar, you choose the 22.1. Particularly if you want to do the energy scale effects, that's why there is a 0.1, because I complained and there was another.
You want to complain in your time because it's my responsibility.
Well, apparently it's effective.
Then you launch it and then you wait. It's black for now. And now when it is green, you click on it be patient because with the internet it is always a bit.
It's not the fastest.
And you should end up here.
Yeah, so there you have my workspace. I mean, this is the place where you have to put everything.
Yeah.
Like assistant, whatever. And then in the Teams workspace, you will see the SAS ACME directory, and inside this directory, the hands-on session, and the README, and the README, because this is a team space, a collaborative space. If we modify the Jupyter notebook that we have there, modify for all. So I mean, in this README, it says, okay, copy the Jupyter notebooks and the tool directory to your workspace, and then your workspace, you can modify the Jupyter notebook, whatever. But this is your topic. If you modify this, modify it.
I think we restricted the access now. We restricted the access, so hopefully it should not happen.
Well, let's.
Yeah, but we'll see. But copy it, and in the case because you can't change it.
You cannot copy because you don't have access to that now because you have to change the permission. Right? And then there is also in the previous directory.
Yes, sorry.
Yeah.
Previous directory.
There's a directory called XMM data. I mean, after lunch, we will see. I mean, we will go through the threads, and in case you don't want to recreate the database, that it takes a few minutes to run the program, we can copy this directory to your workspace where we have, I mean, the event list already there, and we can continue with the thread without having to spend 20 minutes or 10 minutes to run EPICRGS, 10 minutes prog, 10 minutes at this prog, or chain another 10 minutes, so this. So you can copy this directory and you have everything. We can carry on. And inside the hands-on session, we have the EPIC.
You have also the guide for XMM Datalabs if you XMM-Newton in Datalabs in case you need some additional information. And yes, as Aitor said, the EPIC folder where you have 2 examples, and RGS where you have 1 example.
And you go to the home directory. You also, one thing that we do after lunch in the data directory, SAS thread, you must see, I mean, if you have mounted the volume, that by default, the Datalabs mount those directories, so you have to do anything. You have the threads, and those are the threads for the beginners.
Like for example,
so, again, after lunch, now you copy, and because this thread is mounted automatically, you cannot charge those threads. Because if you have those threads, it means that everybody will have a different thread. So again, copy the threads to your workspace, and then there you can execute it, change the ODF if you want to analyze another ODF, or if you want to add a new SAS code, you do it, and then you are not. So project that you have all these things, and if not, let us know.
I have a question. Like, when I have an ODF, you get to load it to my computer and then to upload it to the Datalabs.
I mean, you can actually, I mean, in the thread, I mean, when you, the first thread, when you start setting up SAS, you can put the ODF there, the OXID, and it is downloaded directly to the data. But you can also upload it. But it will take a while. I mean, it is faster if you your Datalabs. One thing that is, I mean, that is also good for these Datalabs is the famous paradigm of bring the code to the data. So Datalabs is close to the archive. So if you have to get it down the ODF, I mean, the transfer from the archive to the Datalabs is second. So if the ODF is private, then you have to enter the credential in the SAS one. Okay. And then I mean, describe the data. You don't put it in a place where you don't. Your workspace, your workspace, you have any workspace.
Yes.
Let me know your.
Here.
Participants. Exactly.
No. Yeah. Okay. Sorry, because I got it. I lost some of the emails on the workshop. So
Everybody received this. Sorry, so somebody received those. You should have received it. There were some.
I received the one of yesterday.
No, but before the start of the meeting. Before the start of the workshop, okay, I think 1 week before, I can check. Sorry, I sent them. You should have received exactly this text.
Yeah, I probably stopped that the program.
Do you need me to send them again? I can do it, of course.
I don't know the space you have.
I actually have it.
And I don't know how much I'm I can just
I guess the server
No, it works on my side.
I guess it's a program. Just but I guess that but I guess this is
We cannot focus. Is the microphone?
Yeah, the microphone is on if you want.
Everybody's talking at the same time.
yes.
Sabella, can you hear me?
Yes.
Otherwise you can change the mic
Otherwise, I will
on
write.
your own.
I will write. Yeah, maybe I can change the microphone to my laptop.
Until what time tomorrow it should be possible?
Hi, yes, I can hear you.
Yeah, we can hear you, Camille.
Yes. Okay. Sabela, I hope you can hear me.
Yes, I can hear you.
Otherwise,
Can you
I will
hear
write
me?
it. I will say it first. You copy to share. You cannot copy a full folder. I don't know why, but in Datalabs at the moment, it is not possible to copy the folder entirely. So you need to copy each file. But you will not need a lot of files. You will just need to copy the notebooks that you would be interested in. So there are 3 of them maximum. In the EPIC folder, you will have 2 notebooks, and in the RGS folder, you will have 1 notebook. So you just need to copy these 3 notebooks if you are interested in them.
Okay.
You don't need to copy the whole hands-on session folder. I will write it in the chat.
Yeah. Sorry, I cannot really, like, it's too noisy.
So sorry, do I understand correctly that you will send us
someone is talking
notebooks before the session?
It's at maximum.
Otherwise, don't talk and I will
Yes. Wait just a second. We cannot hear people talking.
I don't know why. Try again.
No, I was just curious if you're gonna send the link to the notebooks before the session in the afternoon, like so we can use them during the hands-on session already, or.
I missed the beginning of your question.
If you could send or circulate the notebooks you're gonna use before the session, is it?
You can have access. You can. I cannot. Well, I can send them to you, but the easiest way is that you register to Datalabs, and from there you will have an account. And in the email, I will write it in the chat. You receive the code from Paolo to give you the code to access our team workspace, and from there you will have access to all the notebooks that you need.
It's in an email from
okay.
the line.
So let me copy the code. Okay, I will copy all of this.
If someone registered right now, tell them.
Okay. So I use it during the registration, so it will appear in the dashboard or workspace.
Yeah, but if it doesn't work, don't worry. Like just have an account on Datalabs, and then if you don't manage with the registration code, just send me your username, and we will add you ourselves.
Okay, thanks so much. Yeah, I wish this Datalabs work for many more instruments. It's absolutely amazing. Thank you.
For the NASA, I will do the advertising for the Americans, but for the NASA-based missions, you have SAS server, and it works. I haven't used it, but it works more or less the same way. Datalabs is mostly for ESA missions.
By the way, does it exist for the integral, the ESA integral, or?
I don't think so. No, I don't think so.
Okay, thank you.
But if that's something you would like to see, just send a suggestion to the.
Well, it's actually it's a dead mission already, so. But
yeah, but people are still using it. So.
Yeah. Okay. Yeah. Myself too. Yeah. Thank you.
And for Sabela, I don't know if you heard me, but you cannot, for everybody, you cannot copy a whole folder directly from the team workspace to your own workspace. You just copy files individually. It's annoying, but that's how it works. But you don't have too many files to copy, just 3 notebooks. So,
okay.
I heard you. I just wanted to know how to launch the terminal to use the line of the README file. Yes. So normally, even if you don't have the permission for that, I can share my screen. Am I sharing? Yes, am sharing? So if you go on your Datalabs, you go on the XMM SAS instance. And just a second. Yes, so you will see our team workspace for the ACME workshop. And in the hands-on session, I believe you refer to this README file. And what you do, you just, yeah, I see the problem. Yeah,
I copied that line, but I don't
and
know
I guess
how
this is what doesn't work, right? The whole folder doesn't want to be copied, I imagine. That's something. Yeah, I don't know why it doesn't work. I lost you. I heard to launch terminal to use the README file. Yeah. So yeah, to see, I don't know because I have special permission, so I don't know what you are able to do or not. So you just double click on the README file. Here you can see the text. And if you want to, in your workspace, to use the terminal, you click on the plus here, terminal here. And then here you can type the command. But as I said, I don't know if you will be able to copy the whole folder. Maybe via the terminal it works. I don't know. Try and let me know. Worst case scenario, you do the interactive way. You go in each folder, and for example, here, you do copy back to your workspace here, and then you copy it here, doing paste. I'm not doing it because I have other things, but yeah. Actually, I could do. And then you copy everything here. And from here, you will be able to do everything that you want to do. You will have all the permissions that you want. You can modify the text without having issues of permission. We will go through all of that this afternoon. Don't worry if you are not yet set up with everything.
Didn't want to bother you.
I get it. I'll get back to. Okay, the line work. Everything copied. Cool. I'm happy it works. I was wondering if it was because when you do it by hand, doing this, if you copy like this the whole folder, it doesn't work. You cannot do for a whole folder. You need to do it via individual files. But it seems that from the terminal it works, so that's perfect. Okay, are there other questions? No. You can also send me an email if you have I don't know, other technical issues. But we will be here for this afternoon, but in case you want to do it another time, here is my email. Yes.
Camille?
Yes, Natalie?
It's not a question about the work, it's a question about what you're doing technically, because when I tried to share my whole screen, I got the infinity mirror, which I can see here, but you're managing to swap between screens and still show things, because that's what I wanted to do, was share the whole screen. And
so what I did when I entered into share, well, let me do it again because I don't know. Yeah, okay, I entered into share, and then I went, there is a pop-up window that says Microsoft Edge tab, window, and entire screen, and then I went on entire screen.
Yeah, that's what I did, but it makes this infinity mirror, and then it didn't, I had problems with it.
Stay on the Google Meet, where I am right now, it does this infinite thing, but then I just switch tab.
Okay, and it works, okay.
Yeah, it works, okay. The only moment when it does the infinite thing is when I am on the Google Meet here.
Okay, can I try and share the screen again now and see if I can get it to get the whole screen up?
Yes. And if you change tab on the internet, yeah, no, it works. It works like.
And if I use something else, because I wanted to use TopCat and show TopCat and things like that, you can see the TopCat there.
It works. Yeah.
Ah, brilliant. Okay, cool. Then it will work then. Okay, because I was thinking I might have to change all the presentation that I was going to do. Brilliant. Thank you. I shall stop sharing as soon as I work out how to do that. Okay, brilliant. Thanks.
Well, I guess it's the lunch break anyway. So I guess it's the lunch break.
Yes, I think that we can go on lunch break definitely. And probably reconvene at 2 anyway.
Okay.
Okay. We stop the recording and everything, and we'll see you later.
Yeah.
Thank you very much.
See you.